But if you want to test NBMA 5 modes, you need frame relay. We are going to have frame relay. And then we will connect some sites. Maybe I'll connect only 3 sites. Site 1 with one router. Site 2 and site 3 again with one router each. To connect between the sites, we are not having broadband. We are not having MPLS. What do you have? Frame relay. What do you know about frame relay? Nothing. Frame relay is a layer 2 tunnel. Frame relay creates layer 2 tunnel called permanent virtual circuit, PVC. So now if you want to test NBMA, you need to create some PVCs. For that, you need a frame relay switch. But good news is you can also use a router to act as a frame relay switch. That's what I'm going to do. I'm going to take a router and convert that router or configure a frame relay in it. See, I want you to understand this part. Router can be a router. At the same time, it can also be a frame relay switch. For example, these 3 ports are frame relay. Whereas the other ports are OSPF running ports, routing ports. 30001, 40001. Whereas in these 3 ports, you don't have any IP address because they are layer 2 ports, frame relay ports. So you should know this, that a router can be a router. At the same time, it can be a frame relay switch. For some of the interface, it's a frame relay switch because I'm going to say encapsulation type frame relay. For other interfaces, I'm not going to do any changes. So it can be an Ethernet port or a serial port, which can do layer 3 routing. So we are going to have this type of environment. But I'm not going to have routing on the frame relay switch, but I'm just giving you an information that a router can also be a frame relay switch at the same time, both at the same time. You got 3 sites. And will I have any IP address here? Yes. Let's say 10.0.0.1. What about here? Should be also same 10.2. 10.0.0.3. Because the middle one is a layer 2. All the sites need to be in same subnet. Do you understand this? So this may be in Africa. This may be in Australia. This may be in Finland. Europe. But still, no, they have same subnet. They have a layer 2 connectivity, regardless of geographical distance. So we got these 3 sites running frame relay with the help of frame relay supporting cloud in the middle. Early days, every internet service provider were having frame relay. Later, because of advancement and the invention of new protocols, frame relay now considered as a very costly solution. So we don't use frame relays anymore. Why frame relay is a costly one? Because in ISPs, you cannot use a router as a frame relay switch. Here in our lab, we are going to use a router as a frame relay switch. In the ISP, you have to buy a real frame relay switch, which is very costly. It's a frame relay switch that is going to now in the cloud, in the internet. It's not a switch inside your office. Inside your office, you may have 100 computers. You may have a switch that's okay, that is cheaper. But frame relay switch is not cheap. Very, 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 very costly. Now, if you have frame relay switch in Australia, you also need everyone in on the internet, like Africa, Finland, all those ISPs also need to have frame relay switch. Only then the tunnels can be established between the frame relay switches. But what happened is, from layer 2 all started moving to layer 3 because layer 3 devices are cheaper than the frame relay switches, and IP-based routing is recommended instead of layer 2 switching on those days. So we all moved to routers. We all started buying routers. As the customers started buying routers, they can have better, cheaper solution like MPLS, BGP, blah 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 in the internet. So frame relay idea got dropped. Frame relay faded out. You see, frame relay is not cheaper because it needs serial wires. Your Ethernet is everywhere, but you cannot use frame relay on the Ethernet. You need to buy again special adapters, special ports, special wires called serial wire. So not only on the internet side it is costly, even on the customer side they need to buy serial ports, the router, because only on the WAN ports frame relay can be configured. Did you get the answer why frame relay is costly? So we are going to have this topology with 3 sites, and we are going to have a serial wire because we want to run frame relay, and one internet service provider in the middle, which is actually a router with frame relay enabled. And this is what the IP address I'm going to have. Later, we'll have some loopbacks for testing so that we can ping between 1.1.1.1 and 2.2.2.2 and 3.3.3.3 if OSPF comes up in the middle. If OSPF comes up here, only then this route get distributed and ping is possible. So our aim is to bring OSPF over this frame relay cloud in between these 3 routers. What cables I need? Serial cables. So first thing what I will do here is I will go and change the encapsulation type as frame relay for all these ports. And then only on this customer side routers like R1, R2, and R3, I will give IP address. Whereas here, I will not give any IP address. On the router globally, I will enable the frame relay routing service. You don't need to do that on the customer side, because customer routers are routers only, but this is going to be a switch. So I need to globally enable frame relay switching command. Frame relay switching I have to enable. Next, we will yes, in real time, you will have one in Australia, one in Finland, one in Africa, and this when this ISP will talk to this ISP and this ISP, they will all come to an agreement and they will form term. That is another reason why it is very costly. So they all want to earn in the middle. They won't talk on behalf of you without gaining something. Later, things got changed. MPLS came. Everything started changing. We also have a L3, L2 VPN in MPLS. So you don't need any more. Primarily, is you're going to do encapsulation with layer 2 identification called DELC. What? Not LC, not Elizabeth, it's DELC. Data link connection identifier. It's a number, it's a numerical value. Data link connection identifier. For example, if this is one router, I'll say here 102 and here 201 and 103 and here 301. So 103 will connect form PVC with 301. 102 will form PVC with 201. Now, because it is costly, we will not have PVC between this in the real world. But in our case, to make things easier, we are going to have one PVC. For that, I need another number to give. So I'll say 203 and 30. This number I give manually, but on the real devices, on real frame ratios, those numbers are given dynamically. Those numbers are allocated dynamically. Fine. So DELC numbers, data link connection identifier, are like MAC address in frame relay. Using this DELC number only, the packet gets switched from this end to that other end of the tunnel. And there it gets decapsulated and finds the IP address of the destination and delivers the packet to the destination. Fine. எப்படி நார்மல் சுவிட்ச் அதுவே எல்லாத்தையும் போட்டிக்குது பை டிஃபால்ட் ஒரு VLAN நம்பர் 1ல போட்டு அப்ப ஆயிடுது. அது பிளக் அண்ட் ப்ளே தான் நார்மல் சுவிட்சஸ். அதே மாதிரி இது சுவிட்சஸ் தானே. Okay, now we are going to see this. Are you ready for this? Okay. Site 1, site 2, site 3, and a frame relay switch. Let me check whether they have any. Oh, here there is a frame relay switch. Tell me, you want me to use this one, or you want me to convert a router to be a frame relay switch? What do you want? Okay, I'll use frame relay switch. Though I have not used, I know very well it will be much easier than me using a router. So let me delete this. If you want to see me using routers, you can go to my channel and find a video where I have some routers used as a frame relay switch. Okay, so this I need to configure first. It says name frame relay switch. Okay, port number 1 DELC1. Okay, port number 2 DELC. I want to say 201. These two I want to connect. And then again port number 1 I want it to go to router 3, so I'll say 103 and port number 3301 and add. Okay, so for port number 1 we have finished. Now go to port number 2 and port number 201 for the reverse path, other end of the tunnel. 201 should go to port number 101. What? Already defined. Come on. This is from port number 1 going to port number 2. I think it is bidirectional. In the router it is unidirectional. We have to do it. Now what I'll do is I'll go to port number 2 again and say I want to connect to port number 3. So I'll say 203. That's for the third tunnel. Port number 3. I'll say 302. Right, 3 tunnels created. Let me draw a diagram and show you what I have done. What I have done is I've said 102 here, 201 here. This is port number 2, port number 1. And then I said 103 here and port number 1, 2 DLCs, one to go to router 2, another one to go to router 3. I said 103. So I go to port number 3 and say 301. And also I said port number 2 again, one more tunnel, 203, and port number 3, 302. 302, 203. 3 tunnels. Now, I would like to check whether I have a serial cable. Yeah, I have serial port. So I can connect now one of the serial port to the port number 1, which I just created. And then port number 2 to this route. And then port number 3 to this route. I'm happy that my work has become very easy now because I used a switch, which is a movie based. If it would have been a router, it would have been a little bit more configuration. Now, as we already discussed, we are going to make this encapsulation type as flame relay, and we are going to have IP address 10.0.0.1/8. And then here, 10.0.0.3/8. And also, for a reminder, I would like to put the DLC numbers that we used. Here, 1 or 2. I'll go and change it. 1 or 2. That's all. Okay, number doesn't matter. Let it be there. 101, huh? Okay. 101, 201, 103, 301, and in between I said 203, and down here 300. Okay. So we're expecting 3 tunnels to be up. Now let us go to router 1. Serial port number, if you see there, the port number is 60. Sorry, it's 6/0. No shit. Look at this. The default encapsulation type is HTLC. I'm going to say encapsulation frame relay. And then I give the IP address. Done. And also, I would like to have a loopback interface for reachability testing, OSPF. Done. Now, if you notice, I have the IP address, show IP interface brief. And also, if you see here, show IP OSPF interface serial 1/6/0. Not 6/0. What is the interface name? 6/0, correct only. Oh, you should have put IP. Oh, I didn't enable OSPF. Oh, that's okay. Okay, I was not in the intention of showing OSPF. This is the command I want to show. Show interface, not IP. Show interface Ethernet. Sorry, serial 6/0. This is what I was about to show you. You see, the encapsulation type is now frame relay, not HTLC. As I was telling, they use DLCI numbers, data link connection identifier. As of now, it is 0. After we configure, other end we will come and see here. And then LMI type is nothing but local management identifier. Those things are not necessary. We are not in a frame relay class. So let us enable OSPF on R1. As usual, go to loopback and say IP OSPF per area 0. And also interface serial 6/0 enable OSPF. I have enabled OSPF on this interface. Show IP OSPF interface brief. I can see that OSPF is running on both the interface, serial and loop. Now let us go and check the serial. Show IP OSPF in serial interface serial 6/0. You can see non-broadcast as the network type. I said this is the default type. And you see the timer 10 and 30. And there will be a DR-BDR election. So they are waiting for DR-BDR. And one more thing, neighbors will not be dynamically discovered. Neighbors will not, won't be. Fine. Now let us go to router 2 and finish the configuration. Let's like to start router 3. Yeah. On router 2, interface loopback 0. I'm enabling OSPF now itself. And then interface serial 6/0. Done. You see, I have enabled OSPF, but the neighbor will not come. Before that, let us finish configuring router 3 and then we'll go and verify the neighbor and all. Are you with me? Do you follow me what I'm doing? Okay. Okay. On R2, I don't know whether I enabled frame relay. See, I did not enable frame relay on router 2. So if I didn't enable, see how it looks. Show interface serial 6/0. You can see it is HDLC. I'm going to change it as frame relay interface serial 6/0 encapsulation frame. Okay. Ethernet தான். Ethernet தான். அது அப்படி காமிக்கணும் Ethernet தான். R ports in Ethernet. In frame relay, what works is inverser. You see, in frame relay, இருக்கட்டும் சார். நான் தான் சொல்றேன் சார். In frame relay, it is going to be inverser. In Ethernet, it is R. Where is inverser written here? Encapsulation frame relay. Let's see. Do you see anywhere inverser? But that is the truth. In frame relay, it is inverser. Now you see what inverser can do. Now, did I configure any DLCI number on R1 or R2 or R3? Did I configure any DLC number anywhere? Why you are not answering? Did I configure any DLC? No. Okay. I did not configure any DLC number. Show frame relay map. But you see the magic here. It says if you want to go to 20102, which is the router 2, 10.0.0.2, you need to go to 101. If you want to go to 10.0.0.3, you need to go to 103. I did not configure these things in this router. It is dynamically learned through the protocol called inverser. What protocol helps to dynamically learn this? Inverser. As a result, you can ping now 10.0.0.2. You can ping now 10.0.0.3. This proves that the frame relay tunnel is up. Likewise, you can go to router 3 and you can ping 10.0.0.2, which proves that your frame relay is good. But the OSPF is not happening. You see, show OSPF. Not happening. Why? In a non-broadcast environment, neighbor need to be manually configured. So I'm going to say now router OSPF 1 neighbor You have to do this on all router. Even if you form neighbor, you should not leave. See, it says form neighbor, but don't leave like that. You have to do it on all the routers. Only then you will get proper output. Okay. Now if you check the routing table, show IP route OSPF, you can see those loopbacks, and you can ping, and you can ping. And you can ping. Did you understand this NBMA type 1 called non-broadcast? Now, if you check, there will be a DR-BDR election in this. Show IP OSPF neighbor. You see, there is a DR called router 3, and I think router 1 is a BDR. If you go to router 2, you will know. Show IP OSPF neighbor. Yeah, router 1 is the BDR, router 3 is the DR. Okay, so what I'll do is I'll stop here. I want you to do up to this level. Only then the next 4 level you will be comfortable when you do. If all together you will not